Bismillahirrahmanirrahim. How to start a new lecture. Um, Previously, we are discussing eco-friendly reactions, the reactions which are supposed to be non-hazardous, non-toxic for the environment. They are called eco-friendly reactions. In this category, I discussed with you guys was one pot reactions, one pot synthesis, as an explanation. I started off with certain basic examples of discuss that you could go for, let's say, nitration of benzene in the first step, then the nitrobenzene could be reduced in the subsequent step number 2. Then that aniline can be made to react with certain any other molecule, let's say any aldehyde. Subsequently, you can get an imine. It's a 3-step reaction. You could do those 3-step reaction in a single vessel, in a single vial. Initially starting from benzene, putting in the requirement of the nitration, that is nitric acid along with sulfuric acid. Then you can go for reduction and then subsequent reaction with aldehyde and ketone in the same vessel. In doing so, I've discussed that such reaction, because they are being controlled in a single pot, so you are not doing any purification at any step. You are starting at the first step and then you receive the product at the final step. Maybe the reaction is 3-step or 4-step entity. So the middle purification needs not to be done. Finally, you purify the product at the final step. So elimination of purification at 2 or 3 different steps, that saves the involvement of organic solvents, saves energy, as I discussed in the last lecture with you guys. So those become eco-friendly and green reactions. Then I took some real-time example, like the reaction of alkynes along with azides to produce triazoles. Such reactions initially supposed to happen in 2 steps. People produce azides in the first step, starting from, let's say, as we discussed, they start from alkyl halides, react them with azides, let's say dichloromethane, or the reaction usually happens in diethyl ether, and then you get this type of reaction product. Then in the second step, this product becomes a reactant. It's a reactant now. You put in, react this product with an alkyne, phenylacetylene in this case. Some catalyst is required. Similarly, some sort of, let's say, DMF reaction as a reaction medium is required. Then you receive the product as in the form of a triazole. This 2-step reaction was discussed. This step also could be done in this way. Most authentically, you could do that dimethyl formamides. Then people, 1-step and 2-step reaction, they merged it. They performed step number 1 in the flask, adding this one and this one, and when this product is formed, they put phenylacetylene in the same flask. The reaction becomes a sort of a 2-step, but the 2 steps are merged into a single one. It was merged into single one. So you received, we write such reactions like this way. this one, and then you can write it this way, and you receive the product. So both steps has been done in the same flask. The purification steps were reduced, the usage of extraction solvent was reduced, so the reaction time was reduced. So I came to the conclusion that the reactions has become the greener, it has become the economical. That's why it can fall under the category of eco-friendly reactions. So this has been discussed in a bit detail, but with very simple examples, so you people could grasp it so easily. Now to move into next category in the same broader division. The next term is reactions in aqueous media, mean reactions in water. People have tried a lot to convert organic synthesis into greener reactions. I have discussed in previous lectures the usage of organic solvents which are not eco-friendly could be reduced by reducing the number of steps. That's okay, that's fine. The reaction becomes eco-friendly, but not 100%, because at least at the end you need to use organic solvents for the purification, and even for the running of the reaction, at least you need few ml of the organic solvents like DMF, as we discussed in the last examples. So reactions have become greener, eco-friendly, but not 100%. So people came up with another alternative strategy. They said, okay, we will be performing the organic synthesis, we will be doing the organic reactions, but the media of the reaction will not be a organic solvent, like we will not be using dichloromethane, DMF, DMSO, methanol, ethanol. They came up with an idea that why not to use water as a reaction media. The usage of water has many advantages, as we all know. It's pretty economical. You don't need to put in that much of money when you are going to use water as a medium. You take water and you put into the reaction mixer, and you can perform any type of a reaction, Using of water instead of organic solvents ultimately makes the reactions eco-friendly. But as I've told you, all reactions can't be done in one pot. Similarly, all organic reactions can't be done in aqueous media. Only few reactions where the reactants have a sort of chemistry, sort of a nature that they are a bit soluble in water. Then they can undergo reactions in aqueous media. If the reactants are the catalyst, they have the solubility issues in water. They are not soluble. If they are not soluble to that extent, then they will remain sort of unreacted. Mean their yield will be low. 20-30% will be the reaction less. 60 or 70% will be the unreacted material. So such reactions are not preferable where the unreacted remains till the end. However, few reactions are here which are possible to run in aqueous media. So if you have some reactions which can be run in water, they will become perfectly eco-friendly, reducing the usage, not reducing, it will be eliminating the usage of the organic media, organic reactions. Let's say I can explain, I can take one or two examples. can Google, you can search Friedel-Crafts reaction in water, Friedel-Crafts reaction in aqueous media. They are very frequently known reactions. We have an idea in general. Friedel-Crafts reactions mean the reactions of benzene, alkylation, acylation, nitration, this and that. They are preferably done in organic solvents because benzene is an organic solvent. It is soluble in organics, so the reactions are preferably done in organic medias. But with passage of time, people have developed alternatives where benzenes, aromatics, could undergo Friedel-Crafts reactions even in aqueous media. You know, the elimination of, alteration of organic solvents with water. It's really an attractive entity in organic sense. Let me explain the specific reaction, Friedel-Crafts reactions in water in aqueous media. I was going through the literature. I've seen an example over here. In general, this reaction is called Friedel-Crafts reaction. Let's say if we have AlCl3 as the catalyst, we have an idea the reaction of these bodies can generate an electrophile. As per your knowledge, this electrophile will attack at the benzene. It's a sort of an alternating group, so it will favor the reaction at ortho and the para positions. This bodies are sort of withdrawing, it will favor at meta. So meta according to this one, para according to this one, this will be the favorable position. So you guys are supposed to have this as the product, an alkylation of the aromatica ring as per the Friedel-Crafts reaction. Such reactions are supposed to be in certain organic solvents. Organic solvents is a noble natural reaction. A given compound reacts with an alkyl halide in the presence of AlCl3, a nobly known alkylation, Friedel-Crafts alkylation reaction, giving you this product. People came up with another idea. They thought it's a sort of an salt, we have an idea salts are soluble in water. They have a better solubility in water. So they took the same compound, dissolve in water. Instead of taking any organic solvent, they dissolve in water. Similarly, they bring in the reactant as well. This body. This time they did not involve this one. This could also be involved. We have an idea AlCl3 is also salt, it's also water soluble. So it's not a salt, but it's a sort of, we can say it's a negative and positive charges, bit of polarity is there. So any polar compounds can have a little bit of solubility in water due to sort of hydrogen bonding and the other generation of poles, negative and positives. So again, this body could generate the electrophile and we could have the same sort of same sort of a product. If the reaction would have been run in organic solvent, this would be the product. This product in the same flask, this one along with, let's say, DCM I can write, or I can write DMF, dimethyl formamide, water to use this one. So at the end of the reaction, product is there, dimethyl formamide as a solvent is there. So you need to remove this dimethyl formamide. It has a pretty high boiling point. It's also a sort of organic solvent, a bit polar organic solvent. So what you do, you put in, let's say, you put in any other, let's say, you can bring in ethyl acetate as a solvent for the extraction. You need to put that three times, let's say maybe 5 to 10 mLs if you are running the reaction on 1 millimole scale. Then you need to bring in 5 mLs of this body, along with you need to use water to make two phases separate from each other in the separatory funnel. The one phase, the aqueous one, the organic one will carry your product. The water will carry these water will carry the remnants of this body. So at the end, the organic and the aqueous layers could be separate from each other, and then you can go for rotoevaporation to remove the organic solvent to get your product. However, if the same reaction has been run but you have used the water, so what will be there? You will have your product, this body, and you will have a water over here. Your water over here. Now you don't need to go for extraction. You don't need to go for extraction using ethyl acetate 3 times along with water. You can simply evaporate the water. Evaporate the water, then you will have your own product only remain inside the flask. You can bring in recrystallize that. You can recrystallize. And recrystallize the product. So by doing the reaction in aqueous media, you have eliminated the extraction process. So you have eliminated the usage of organic solvent at the 2 steps. One at the time of the reaction, running of the reaction. Secondly, you don't need to put in the, preferably, sometimes you need to do, but preferably I would say, you don't need to do the extraction with using organic solvent. You can simply use evaporation or recrystallization, this and that, to get your products. So such reactions are called green reactions as well. Yes, because the usage of organic solvent has been eliminated. Sometimes it has been seen that the reactions, when you run them in organic solvents, you receive the products. But on the other hand, when you run the same reaction in aqueous medium water, in general, your requirements are changed. Mean this catalyst, if it is suitable in organic solvents, maybe this catalyst will not be suitable in aqueous media due to solubility issues. We are lucky in this case, the catalyst is a sort of a salt, soluble in aqueous media as well, so you can continue with the same. But sometimes there are catalysts which could have solubility issues in aqueous media. Under such conditions, the reactions, the products, they could be achievable from the same reactants, but most of the times your catalysts, co-catalysts, they are changed to some more suitable species. Like this in the literature, I've seen this one. This when uh, this reaction is being run in aqueous media, they are using some sort of mesoporous oxide instead of AlCl3. They have used a catalyst that is called they are using some sort of oxide with having mesoporous morphology. This is what I'm trying to say. It's not that easy to convert every reaction into a reaction that can run in aqueous media generally due to solubility issues, either due to the solubility issues of the reactants or due to the solubility issues of the catalyst. So sometimes the catalysts which are used in general in organic solvents, they become less usable in aqueous media. Whenever they are used, their product is received in low yield. They become low yielding catalyst just with the change of the aqueous reaction media from organic media to aqueous media. So that's why they cannot be economical. Most of the time they cannot be economical. They become greener, they become eco-friendly because the water has been used, the organic solvents has been eliminated, but the change of catalyst from this to this may cost more. If the catalyst which was working better in organic solvents, okay, that becomes less usable or less efficient in aqueous media, then people go for some alternative catalyst which could be more efficient in aqueous media. So change of the catalyst, it can be expensive. Let's say it can be expensive compared to this one, though this is not sort of a cheaper one, but even then it can be more expensive than this one. So when people try to convert the general organic reactions which happen in organic solvents into reactions which run in aqueous media in the same one, there are chances that we can convert them into greener one. We can make them eco-friendly one. But there are chances that they can become greener, they become eco-friendly, but at the same time the reaction cost could increase. That's why such reactions are not attracting for the industry. It is interesting, attractive for the industry, usage of water. You know, if somebody has to use 10 liters of dichloromethane or 10 liters of DMF in an industry to run any reaction, you can imagine how much it can cost. If the same industry has to run the same reaction in aqueous media in water, you can imagine it will cost almost nothing. They can just put in cans of water from the tap and just throw it into the reaction vessel, a big tank. They can fill in with water, no problem at all. But changing of the media from organic to water, that's an easier, but at the same time, change of the catalyst from here to here, maybe it can cost them 10 times more. So it will not be attractive for the industrialist then. However, for the people who have concerns regarding the environment, who want to run the reaction on an eco-friendly scale, they will try their hard to use water instead of organic solvents, and then they can go for expensive catalyst as well instead of cheaper ones, because their goal is to make reaction greener, not the cheaper. So cheaper and greener, they can't be together. They can't be together, especially at the industrial scale. So that's the way, that's the big issue, big problems, that these reactions, aqueous reactions in aqueous media are one pot reactions. They are not very attractive, or they are not applicable to each and every reaction, especially on industrial scale. A lot much research needs to be done. Let's say if people with passage of time could develop alternatives of catalyst which can be a cheaper catalyst with water, that will be a sort of a double attraction for reactions at lab as well as for the reaction at the industrial scales. So whenever any reaction schemes are presented, reaction schemes are formulated, reactions are designed for the preparation of any product, all these things are kept into mind. Either the reaction can be one pot, whether they can be run in aqueous media. If they can be run in aqueous media, what will be the change from the general scheme, mean what sort of the catalyst will have to be changed, then whether that new catalyst for aqueous media will be an economical option or not. If economical, then such reactions are recommended for industrial scale, for the preparation of medicine, for the preparation of dyes, for the preparation of agrochemicals and many other industrial products. If the reactions requirement, catalysts and other auxiliaries, they're expensive, even though eco-friendly, the industrialists, they will not opt it, they will not follow it. Even you recommend them with strong, I would say, strong recommendations that it is economical, it is green, this and that. They need economical first, then the eco-friendliness or greener approach comes afterwards. So whenever you look into any reaction, you should try to think whether the organic solvent could be changed with the aqueous media. If so, then after that, what's about the conditions of those reactions? Whether they could also be changed or they can be kept same. Let's say there is another option. If you just change the solvent from organic to inorganic water, but you keep the requirement, the catalyst same, as in this case it can work in both because it's a salt, it can work over here. It will be the best option for the industry. Okay, the rest is the same. The expensive organic solvent has been changed with the water. They will really appreciate your efforts because it will become a lot more economical for them due to just the replacement of water. However, in cases when this option is not the same, then you need to find the alternative catalyst which are also cheaper. Then you can recommend them for their use at the highest level. So this is what I'm trying to convey. This is what I'm trying to say, you guys. Eco-friendly reactions which are run to save our environment. From the last few decades, around the world, people, general public, have got the awareness about the chemicals and their side effects and their hazardous effects, their threats for the human life, for their aquatic life. So people have got the awareness now. So even the governments and the government agencies are trying to enforce such legislations, rules and regulation on industry so that they can opt greener reaction, eco-friendly reactions. In case of eco-friendly reaction, 2-3 options are available which they could follow. Yes, they could make the reaction one pot. We discussed that, how they could be eco-friendly then. And at the same time, I've told you the limitations over there as well, that every reaction cannot be one pot. Similarly, into the next eco-friendly reactions, but the next category becomes, okay, the reactions are not one pot. they required 1, 2, 3 steps. Okay, fine. But if you change this use of organic solvent with the aqueous media, even then the reaction will become eco-friendly because the organic solvent has been replaced. But that's become the big issue. If the reactions requirement changes from organic to aqueous media, then you need to bring in certain alternative catalysts which should be the economical one. If they are not economical, then it will be hard to compel industry. It will be hard to make them understand that it's a greener, it's eco-friendly. So being chemist, I require you guys. So whenever you design any synthetic strategy for any product, you need to keep such things in mind. The requirement of the reactions, and then you can recommend whether the reaction can be done in aqueous media or not. If the availability of cheaper catalyst is also there along with the usage of water, then you can really make the difference. Otherwise it will be hard. However, at the moment, what I'm trying to convey you guys, eco-friendly reactions. So in that eco-friendly reactions, you have gone through two categories now. One is one pot where we reduce steps. So that's why those reactions become eco-friendly. The second category, we don't reduce step. Reduction step is also fine, okay. If we can't reduce the steps, even then if we eliminate the usage of organic solvents, we replace the organics with water, they also become eco-friendly. So two main types of reactions has been discussed till to date which fall under the term of eco-friendly reaction. I think you got the concept now. I would urge you to look into the literature, go through the Google and find out certain examples of reactions in aqueous media, especially Friedel-Crafts reactions in aqueous media. They are of your level. We have already discussed simple and normal reactions of benzene. If you find the reaction of benzene in aqueous media, that will give you the best comparison between the general reactions in organic media and then the same reactions of benzene in aqueous media. With that, I really appreciate and thank you very much for listening with patience, and I do hope I will receive the feedback from you guys. Thank you very much. Assalamu alaikum.